So I had quickly tried to grab some carbon capture system designs and I tried to parameterize them. Um, I looked at different companies and what they described were things that they did. So I looked at Burdock's, this was kind of from their paper on electroswing, calcite, these were all X Prize winners. This was their about section. They use, I think they use calcium hydroxide to capture, which is also how carbon engineering works. And then Carbion, they didn't provide that much information, so I wanted to see what would happen if ChatGPT tried extracting parameters from these very little information, but still valuable information. And so I asked it to extract parameters based on system parameters and system metrics. And here we get some extraction. And one thing to notice is that while they both share technology type, one has like process, one has electrode material, because some are just more relevant to another. And yeah, for the one with the little information, there's also like very little information on technology type, which might be a little bit difficult to figure out how to use. But the next step was trying to create a generalized universal carbon capture system from the set of parameters because you saw the parameters were different. And so I decided to create one for technology type, capture medium, reaction mechanisms, concentration range, and it has all these kind of system metrics that I don't think was what I kind of intended, but we really care most about the parameters. So like what's the CO2 concentration range, what's the reaction mechanism, what's the material, and what is the technology. And the idea is that you would want to be able to like mix and match between them and get an answer. So I said, let's say I chose the following parameters, electroswing and calcium hydroxide, which doesn't make sense. I also chose two technology types, so that probably shouldn't even work. But it's able to evaluate and actually say that it might not be feasible, which makes sense, right? Like you're trying to use electricity to drive some kind of material that isn't electrically reactive. So yeah, the answer is that it shouldn't work. So it's not a correct solution, and it doesn't estimate the energy consumption because it's not well aligned combination. So that was pretty good. It was able to evaluate decently. And then I gave it a more realistic example, which is reactive absorption, calcium hydroxide, and carbonation reactions, which I think is how calcium hydroxide works to form calcium carbonates. And I just said low CO2 concentration range because that's generally what happens when you try to capture CO2 from air. It's very low. And it was able to go through this logic. It said that it is indeed feasible, which is very common knowledge. I think one of the companies above also did something like that. And then it gave me a broad estimation of the energy requirement. And really what we're going for here is just a coarse idea of what the energy requirement would be like. If it said that it would be 20 gigajoules per ton of CO2, we can probably say that it's probably not an avenue conceptually that we should go down and try to refine. The idea is that once we get something really low, we should be able to kind of focus more in on that and optimize that process instead of spending time on more higher energy consumption methods. And so this was pretty cool. We were able to take a bunch of system designs and try to extract parameters from them. Now I'm still trying to figure out if these universal parameters are actually the best parameters. I'm thinking that maybe a top-down approach might work better because that's what worked better when I was creating a taxonomy, like having experts create what parameters you need so that if you have these parameters, you can estimate the energy consumption. That would be pretty nice. And then if certain research papers, because eventually I want to extract this type of information from research papers, and they probably don't cover an entire carbon capture system design, but they might provide an interesting material. I'd like to be able to add that as one of a material capability, another parameter that you can play around with. And then the idea is that you can mix and match and kind of find the best parameters to optimize whatever metric. So in this case, energy efficiency. So yeah.